Welcome to qnawire.
For part A of this question, we're asked to find the velocity vector v, which is the velocity in the x direction plus the velocity in the y direction. And we're also asked to find the position vector r, which is the velocity or the position in the x direction as well as the position in the y direction. So really we need to find v of x here and v of y as well as x and y. So we can start with finding the velocity in the x direction. We find that this is equal to, of course, the integral of the acceleration in the x direction with respect to time. Okay, well, the acceleration in the x direction we're told is equal to the constant alpha, which we're given, times time squared. So if we carry out this integral, we find that this is equal to 1/3 times alpha times t to the third plus the initial velocity in the x direction, which is v naught x. So we can box this in as part of our solution for part A. Okay, let's start a new page here. Next, we need to find v of y. V of y is equal to the integral of the acceleration in the y direction, of course, with respect to time. In the question, we're given that this acceleration is equal to beta minus gamma times time. Carrying out this integral, we find that this is equal to beta times time minus gamma, well, 1/2. From the integral, you get that 1/2 there. 1/2 gamma times time squared plus the initial velocity in the y direction, v naught y. Okay, so there's the second part. So those two together give you the velocity in the y direction, or excuse me, the total velocity as a function of the velocity in the x direction and velocity in the y direction and a function of time here. So now we need to find x. Well, of course, x is just going to then going to be equal to the velocity in the x direction times time. The initial velocity in the x direction times time, right? So that's going to be the initial position from that value plus, and then you just do the integral of the v of x. That integral is equal to 1/12 alpha t to the fourth. We can box that in. Lastly, we need to find y. Y then is just going to be the integral of v of y. So that's going to be v naught y times time plus 1/2 beta. Let's rewrite this here to look a little neater. 1/2 beta times time squared minus 1/6 gamma times time to the third. And this can be boxed in as the last part of our solution to part A. So those two together can make up your position vector. Now for part B here, let's start a new page. Part B asks us to find the magnitude of the height that the rocket goes. And we can do this by finding the velocity at that magnitude, which has to be 0 because it's at the peak of the launch, and then using the quadratic equation to find the time it takes to get to the peak of the launch, and then using that time to plug into our y magnitude to find the magnitude of the height. So first, we're going to use the fact that v of y at the peak of the launch, or excuse me, at the peak of the height of the rocket's launch is equal to 0. and this is equal to v naught y plus beta times time minus 1/2 gamma times time squared. Okay, so using the quadratic formula, using an only positive value then is t is equal to beta, negative beta, plus the square root of beta squared minus 4 times negative 1/2 gamma. Go ahead and extend this on. Multiplied by v naught y. And this is all divided by negative 2 times 1/2 gamma, or just negative gamma. So this comes out to equal 13.59 seconds. We can now use this time, plug it into the equation for y. So if we go back here, so plugging it into this equation for y, and then all the other values we were given for v naught y, for beta, for gamma, we find that the y value is equal to 341 meters. And we can box that in as our solution for B. Lastly, for part C, we're asked to find the position when y is equal to 0. So we can first find the time when y is equal to 0, again, using the quadratic equation. And then using that, we can find the position. So y is equal to 0. And we know that y is also equal to v naught y, the initial velocity in the y direction, times time, plus 1/2 beta times time squared minus 1/6 gamma times time to the third. Well, since everything on the right side of the equation has a time in it, but the left side of the equation is equal to 0, we can just divide by time. So that time goes away, the squared goes away, and that third becomes a time squared. Now, using the quadratic equation, we have time is equal to, and we only want to, again, consider the positive time. You have negative beta over 2 plus the square root of beta squared over 4. So beta squared divided by 4. And then you have minus 4 multiplied by negative gamma over 6 multiplied by v naught y. And this is all divided by 2 times negative gamma over 6, or negative gamma over 3. So carrying out this expression, we find that the time it takes for y to equal to 0 is equal to 20.73 seconds. So we can take that time and plug it in the equation for x, as well as the value for alpha and v naught x, and we find that that position is equal to 3.85 times 10 to the 4, and the units are meters. And we can box that in for part C.